going to start this off by just doing 2 simple questions with you, and then we will I'll explain what they're doing now. Okay, so if I have this, and I said to you, okay, solve for this over 0 to 360. No, let's do it right. Let's work with radians. Okay, so I ask you to solve this now. Where is sine theta? For what angle of theta does sine theta equal -1/2? Oh, sorry. Okay, so it's -1/2. So first thing, here's what I'm suggesting you do. This can be done easily by looking at your unit circle. All right? But what I want you to do is I want you to get into a practice of saying, what is the reference angle for this? Okay? So where does sine theta equal 1/2 in the first quadrant? What's your angle? What's your angle in the first quadrant? Angle? Yeah.
30 degrees.
Work with radians, please.
Pi over 6.
Okay? So in the first quadrant, it's pi over 6, right? So what are the 2 quadrants? What are the 2 quadrants that sine is negative? Which one is it?
1 and 4.
Because sine is what? Your y. So 3 and 4, we agree? Yeah? Okay. So now, in quadrant 3,
7 pi over 6.
7 pi over 6. Quadrant 4,
11 pi over 6.
we all agree. Yeah? So far, so good? So that's just very basic. All I'm asking you is, for what angle of theta, I need you to think this through, because it's going to get a little more complicated. For what angle of theta is the sine ratio equal to -1/2? That's what I'm asking you. Right? Okay so far? Okay. Okay, so what am I asking? Oh. Yeah, I don't know. Yeah, go ahead. Oh, yeah, thanks. Hello? Yeah? Okay. 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 Yep. Okay, perfect. Thanks very much. Okay, bye.
Excuse me for the interruption. Mr. Halidi, call 15,000. Mr. Halidi, call 15,000.
Okay. So what am I asking you here again?
For what angle of theta is the tan ratio -0.1234.
Perfect. Okay, so let's find it in our first quadrant. And again, let's work with radian measure. So 0 is less than, theta is less than 2 pi. Okay? So now you got to use your calculator for this. Make sure your calculator is in radian measure. All right? And I don't want the negative. I want the positive. I want the first quadrant. Okay? What is it in the first quadrant? It's not going to look normal to you. What is it?
I think it's 0.123.
It's what it is. Okay? That's what it is. That's just using your calculator, okay? Now remember, the first quadrant is 0 to pi over 2, right? Well, pi over 2 is like 1.5. So you're going from 0 to 1.5. So does that fit in the first quadrant?
Yeah.
Yeah, for sure it does. Okay, what quadrants are tan negative in?
2 and 4.
2 and 4. So I need this angle right here. How do I get it?
Subtract 180 from that reference.
You can't. You can't use 90. I'll tell you why in 1 second. But I know that this is the reference angle right here. This angle and this angle are the same, right? And all the way around to it is what? Right?
180.
Pi.
1 pi, right? So take pi and subtract that, please.
That's 3.019.
Okay? And then I need it down here too. There's my reference angle. I want that guy. So am I getting that one?
2 pi subtract 0.123.
2 pi subtract my reference angle.
You want us to use pi or 3.14?
2 pi. Use your pi button.
6.16.
6 point what?
160.
60. You gotta go to 3 decimal places every time in this section. Okay. There's 2 questions I just did. 1, your ratios were on the unit circle. 1, your ratios were not on the unit circle. Okay? Do you understand this? Because it's gonna get complicated. What's the problem? What do you mean? Pardon me? No, no. Where are you? Like, I'm just trying to think how I can. Well, let's go back to this guy. This guy's a little easier.
I understand this one.
Okay. All right. Let's say that you didn't know. Let's say that you didn't know that the sine of pi over 6 or the sine of 30 degrees was 1/2. Right? So you'd have to use your calculator to find out second function sine, the ratio. Right? So you could do this whole question. Let's do it right now. Punch into your calculator, second function sine 0.5. What do you get? 3 decimal places. What is it?
0.524.
524. Okay. That's what pi over 6 is for the record. That's what pi divided by 6 would give you. Is this. Okay. You understand that part? So now I need this angle in quadrant 3. So I want that angle right there. Now the angle that's made with the horizontal is always that. So what is this angle to right here? Pi, correct? 1 pi. And then I would add my reference angle to get this angle, correct? Okay, so now take pi and add it to 0.524, and what do you get? Which is 7 pi divided by 6. Okay? And then I want to find, in the fourth quadrant, that guy down there, in which my reference angle is this. So all the way around to here is what? 2 pi. So if I only stop right here, I take 2 pi and I subtract this, and I'll get it, correct? So now I take 2 pi and I subtract that, and I'll end up with 11 pi over 6.
Okay. That makes sense.
You follow that so far?
Yeah.
I did the same thing here, it's just I didn't know what this angle was without using the calculator. You okay?
Mhm.
All right? Because I'm gonna amp this up a little bit here. So I just need you to, if you can get these 2 pieces down, everything else is exactly the same, it's just a little bit more algebra, but it is the same thing.
Okay.
You okay so far? Does that make more sense than what it did 5 minutes ago?
Yeah.
Okay, so I'm gonna try the next one. It's a little more complicated, but, all right, so let's look at 139. 7 cos theta plus 5 equals 2 minus 3 cos theta. All right, so this looks a little complicated. So 7 cos theta minus 5 equals 2 minus 3 cos theta.
Plus 5.
Plus 5? Yeah, thank you. Okay, it's important. All right, so, don't write this down yet. Let's write this down. My objective here is to get cos theta isolated by itself. So I want the cos thetas to one side, and I want my numbers on the other side. It's just like solving, if I gave you this,
2 minus 3x.
and I asked you to solve for x, what would you do?
This is okay.
Okay, so let's do it. Let's do it right now.
Add 3x to both sides.
Add 3x to both sides, that gives me 10x over here, right?
Subtract 5 from both sides.
Subtract 5, so that gives me negative 3 over here.
Okay.
X is equal to
Negative 3.
negative 3 over 10. We're all good with that? Okay. I just did the same thing here, and what I end up with? Cos theta equals 3 over 10. Okay, so far? All right. What's it asking me?
What, for what angle theta is cos equal negative 3 over 10?
That's right. So let's find our reference angle first. And notice, this is good practice for you. Draw this out. Draw it out. It tends to make more sense if I can see it. All right, so I need this, and what does it give you as your domain? Degrees or
Degrees.
radians? Degrees?
It's
Okay, so let's find this in degrees. So switch your calculators back. What's my reference angle?
107.458 is what I got.
You got 107.458?
No, that's not.
Yeah?
But that doesn't
But that,
make sense
Yeah.
because
Why?
that's not in quadrant 1.
That's quadrant 2. Good. Good pickup. That's excellent.
Oh, but it's negative.
It's negative. But what should I punch into my calculator to get the reference angle?
Just not negative.
No negative.
3 over 10.
Yes. So what is it?
72.542.
Perfect. Degrees. 72.542 degrees. Now, quadrant 2, right? What's the other quadrant that cos is negative?
3.
So I need it in quadrant 2 and quadrant 3.
$107.458.
What? Thought you just said that.
Yeah.
There's the beauty of this question. When you find your second function cos when it's in negative, it actually gives it to you in the second quadrant. Okay? But as long as I keep practicing the same procedure here, you can't mess it up. So find the reference angle first. So now, I need the third quadrant. What is it in the third quadrant?
232.542.
And the question's done. Okay, so far? Jesse, did you follow that one now?
Yeah.
Yeah? So when I look for the reference angle, what do I need to remember? Always do it as a positive. And it was good of you to pick it up in that second quadrant and say that didn't make sense. That's awesome. But it did give you one of your answers too. And it will. You'll always get one of your answers. Okay?
Include some.
If Sine actually will give you down here, it'll give you the negative angle down here.
Okay.
But, which is the right angle, but you wanna find the positive angle for it. Okay. Okay so far, because this is gonna take to a new level in the very next question here. Okay so far. Alright, so what did I solve for? I solved for my cos theta, right? And then found my values around the unit circle that it worked. Okay? Good? Alright. Next one, 17 plus 3 cotan theta equals 29. In general form, okay. So. Got that, right? So what do you suppose I'm solving for?
Cotan.
Cotan theta. Okay. Subtract 17, you agree with me?
Yeah.
That gives me 12. 12 divided by 3? 4. So cotan theta is equal to 4. But I don't have cotan theta on my calculator. What do I have?
10.
I have tan theta. So what is tan theta actually equal to here? If cotan theta is equal to 4, what is tan theta equal
1
to?
over 4.
Awesome. Just reciprocal of it. All right? Now, you're going to find this for me in radians. Because it says general form, it means radians. So I want you to find me in radians the reference angle to begin with.
I got 0.245.
Do we agree?
Yeah.
All right. What two quadrants are tan positive in?
1 and 3.
1 and 3. So we already have the 1, right? Agreed? So now I need the 1 and 3, which is down here. So how do I find the 1 and 3, Jesse?
You add 2 on top.
What'd you get?
Would it just be 1 pi that you add?
Yeah.
Yeah.
Add 2 pi. Add 1 pi?
Yeah.
Oh, I thought you said add to pi.
No.
Okay, so add 1 pi, right?
Yeah.
And what do I get?
3.387.
Okay. Now, cancels down. General form means two things to you. Means you have to find it in radian measure. Casey, pay attention to this.
Yeah.
And it also means that you have to find the infinite amount of solutions. Okay? Which means you have to keep going around and around and around and around and around and come back to that point every time. So when it asks you for general term, I've already showed you this, so it's not new. How do I find the next exact value to this guy?
Add or subtract 2 pi.
Add or subtract 2 pi to it, right? So here's what I do in general form only. Put my answer, add 2k pi, in which k is an integer. So that's all you have to do. But when they ask for general form, they ask you to add that into it. Saying, if I continue to go around the circle and come back to that point, I'll always hit it.
So
And then I put it, go ahead and ask your question.
is K the amount of times you were?
Yes,
Okay.
yes it is. We used n this week. We used n, and n was an integer or n was a natural number. They usually use k pi, or k, 2k.
It doesn't have to be plus minus.
No, because I put it as an integer.
Oh, okay.
So an integer means negatives and positives, right?
So
I don't like the way they did that with the natural numbers. It confused you.
Yeah.
Right? Because you needed the plus minus. Put it as an integer, never wrong, the correct information. So k represents the number of times I go around the circle in a positive and negative direction because it's an integer. And that's in general form.
So you have to do that for all your.
in general form.
Okay.
Okay? You guys, you follow that? So that's to the next level again.
And that won't change ever.
Okay, I'm gonna show you one more. I'm sorry, I'm taking all your time. I'm gonna show you one more. All right? Ready? First of all, actually, again, same steps that we did. We did this exact question already with point 1, 2, 3, 4, right? Correct? So from there, all of this is always the same. This right here is always the same. It's just, they'll switch your equations up and that's it.
I have a question.
Sure.
How do you know that tan is positive and 1 is 3?
Because how do I find tan on the,
Opposite over adjacent.
okay, but when it comes to coordinates, how do I find tan? It was y over x, right?
Oh, so then when
So
they're both negative, they turn into positive.
Exactly. Right? That was one of the first things that we learned in this section. Sine was your y value, cos was your x, and tan was your y over x. Okay? So both positive or both negative, you got that. That's a good question. All right. Okay, let's look at this next one. 2 sine squared equals 1. All right. Again, we're going from 0 to 2 pi as my domain. Now, there's 2 ways in which we can solve this question. All right. The first way to solve this question is to isolate the sine squared. Okay, so let's do it that way and let's keep it consistent. So sine squared is equal to what? 1 theta equals half. Don't forget that. Always have your thetas in there. Now what do I do next?
Square root it.
I'm going to square root it. So that gives me sine theta is equal to,
1 over 4.707.
no. What's it equal to? Plus minus. Okay, there's the first thing that's important to us. You have to have the plus minus in there. Okay? Because you're taking the square root. What is the square root of 1?
1.
It's 1.
1 over 2.
1 over root 2. Which, when rationalized, is what?
Root 2 over 2.
Do we know that guy? That's what?
45 degrees.
Plus minus. In radian measure. What is it?
Pi over 4.
Pi over 4. Next.
2 pi over 4 is 90. So 3 pi over 4.
And then
5 pi over 4, 7.
there's your solution for that question. And it was on our unit circle, right? So we have to be able to identify 1/2 root 3 over 2 and root 2 over 2. So wasn't that question wasn't that difficult, except for this part right here. Okay?
If there's a square and it wasn't on the unit circle, you just do it like the questions we did before.
Then you would have to find all the positive and negative. So you start with your reference angle, and then find quadrants 2, 3, and 4.
So if this asks for general form,
If this one asks for general form, I'm going to tell you to do the same thing. List them and add 2k pi. There is a different way in which I could do this. I'm going to show it to you, but in the next 30 seconds I want you to forget about it. It should be hard, right?
Oh,
Okay.
yeah, it's great at forgetting.
Pi over 4. All right? These are all odd values of pi over 4, right? How do I make a number odd? Okay, first of all, how do I make any number even? What do I do?
Times by 2.
Times by 2. So to make it odd, I can do what? Times by 2 and add 1 or subtract 1. You agree with me? Okay. So these are all odd numbers. Of pi over 4. right? That's the shorthand way of doing it. And that describes all of them in general form. Don't do it, forget it. Do not remember that. Okay? So what I would like to see you do, and then this way you won't make mistakes on it, is list all of the once around the circles, and then add 2k pi, add 2k pi, add 2k pi, add 2k pi. You'll never get it wrong then. Okay? And it doesn't overcomplicate things. You don't have to think it hard, you just gotta list them and add 2k pi each time. Okay? But this is the short form of this. This represents all odd values of pi over 4 where k is an integer. Okay? Scrap that. Alright.
How does that work though?
What do you mean?
Well, cause like for like K, like how would you do it? Like say you went,
So
Yeah.
once. So if k is 1,
yeah, okay.
right? So that's 2 times 1 plus 1. So that represents 3 pi over 4, which is your next one.
Okay,
And if k is 2, 2 times 2 is 4, 4
Okay.
plus 1 is 5, that gets to 5 pi over 4, which is your next one. Right?
K equals 1, does that mean it went around the whole circle just once?
Nope.
Or
No.
is that the original?
That just means that no, it doesn't, because, how do I explain this to you? You're multiplying it by 2 and adding 1 to it.
Okay.
And then timesing it by pi over 4. Alright, so in this case here, because I'm timesing that 1 by 2 pi,
Mm-hmm.
2 pi represents once around the circle. Right? Agreed?
Yep.
Over here, this represents 1 value times a quarter of the way around the circle. Not even a quarter,
Yeah.
it'd be an eighth of the way around the circle. Right? So whenever you put a number in here, that's 1/8 of what you're supposed to get to your next number.
Okay.
Okay? That's why I don't want you to play with that. I don't want you to think about it. I don't want to confuse you. Okay? All right, we only have 8 minutes left. Let's go back through questions from the last section.
Can you put this looking like?
Like what I just did? Yeah, I'll do that right away here. Okay, in fact, I'll shut it off and I'll start that.